Hello, this is Dr. Keith Miller, and in this hands-on video, I'm going to be discussing topographic maps, both the making and interpretation of topographic maps. A topographic map is a type of contour map. Contour maps are a way of displaying any kind of data that can be presented in a map view. So you can contour, say, barometric pressure, or temperature, or rainfall, or vegetation type, or any kind of data that you can put on a map, you can render as a contour map. And in a contour map, you're drawing lines that connect data points of equal value. So within on a given line, all the points, all the data points on that line are the exact same value. So in the case of a topographic map, what you're contouring is elevation, so that every point on a contour line is going to be the same elevation. So a couple rules about contour lines. One is that all the points on one side of that contour line are of a higher value than that contour, and all the values on the other side of that line are of a lower value than that contour line. Also, contour lines cannot intersect. Obviously, the reason two contour lines cannot intersect is because you cannot have, in this case of a topographic map, a single point that is simultaneously at two different elevations. So contour lines will never intersect. Also, the spacing of contour lines indicate how fast those values are changing. So again, for a topographic map, the closer the lines are together, the steeper the topography. So you're going uphill or downhill more rapidly. If the contour lines are much farther apart, that means that you're in a much shallower, what's called a gradient, so that the elevation changes much more slowly. There are a couple other rules that I'll mention as I proceed. So the best way to understand topographic maps and understand the rules is to actually make one. So the first step that I'm going to take is to make a contour map given a map with data points, with elevation points. Using those elevation points, then construct a topographic map. So let's do that. Okay, now that I have things set up, we can proceed. So what we have here is a contour map, and each of these points is an elevation point. Okay, so these numbers, let's say in this case, represent feet above sea level. And the first thing you want to do when you look at a set of data points like this is to find out where the high points and low points are. So you have an idea of where the high areas are and the low areas, right? So if you look here, you see high values right in here. So 710, 810. These are the highest values on this side of the map. And the values get smaller in this direction, and then they start getting higher again. And again, your highest values on this side of the map are over here. So the immediate thing you see is that you have a high area on this side of the map and a high area over here with a low area or valley in between. So it's good to have some sense of overall of what the topography is before you begin. Okay, so when you want to draw contour lines, the first thing you want to determine is what the contour interval is. That is, how much distance there is, how many feet there are between any two given contour lines. And looking at this map, it seems like a logical contour interval is 100 feet. right? So we're going to draw contour lines at 100 feet. So every contour line will represent values of multiples of 100 feet, right? So we'll just go ahead and get started. So also note here that running through the center of this map is a stream. Well, that stream is obviously going to be the lowest point, because the water is going to run down to the lowest part of the topography. So we'll start next to the stream and then work our way out. So here is a value of 210. So we're going to draw the 200 contour. So we'll start up here. And we'll go down, and we want to come just inside of this data point. So everything above this contour line is going to be above 200 feet. Everything below that contour line is going to be below 200 feet. So we want that contour line to pass that point. And then we go here, we see here's a 300 and a 100, 305 and 100. So we want to kind of go in between those two. Like that. Over here is another 330, so we want to stay inside of that quite a bit. So there's our first contour line. Well, here's a 100 value, so that should sit directly on a contour line. So we'll draw another contour line. It'll pass now right through that point, because that's right on 100 feet. And then continue it over. You want to have your contour lines kind of spaced as much as possible, as even as you can. You don't want to make sharp turns. You want to make smooth lines between your points. So we'll just finish on this side of the map. So we have 200, so next we want 300. Well, here's a 305, here's a 350, here's a 400. Right? Here's 210, 400. So we have to go kind of halfway in between those. This is a 300 contour. Here's 350, so we want to pass inside of that. Here's 305. So 305 is just higher than that. So the line will go right close to that, but it won't go through the point. And we keep going. Here's 330, so we want to go a little more to the inside of that one. Okay, so that's our next contour line. Then 400. Well, conveniently, we have a 400 points. We can go right through that one. So here's 350, 500, 505. So we want to go closer to the 300. Here's another 400, so we go right through that point. Here's 480, 460, 330. So again, we want to stay between those. So there's another contour line. Next is 500. Again, here's a 500 value, so we go right through that one. Here's 500, so again, we go close to it, but not through it. So we can't go through that because this line has to, all the points on this line have to be exactly 500 feet, and that's not 500 feet, that's a little above, so it can't be on the line. So we don't connect dots. Here's 480, so that's going to be below the 500 point. Here's 460, that's going to be a little further below it. So that means this line has to curve over so as to miss at 460. Next is 600. Well, here's 640. Here's 710 and 5. So we want to go halfway in between there. So it kind of says we go like this. Here's a 600. So we can go right through that point. Here's 650. So we have to go inside of that. And here's another 600. So we know the line has to pass through that point. So we're getting our map. The next would be 700. Well, here's 710, but there's no other 700s here. Notice over here, it's 600, 500, 300. We're going down again, right? Down here, we have 600 values, 600. So this suggests that we have the top of a hill here. So we're going to have a closed circle. So this is another rule of topographic maps. All lines, all topo lines on a topographic map have to either go off the edge of the map or they have to make a closed circle. You cannot just end a topographic map in the middle of your map view, okay? Because that suggests that somehow or other that elevation just ends. It can't, it has to wrap around, right? So here we have 710, here's 800, so we have to enclose that. We have to be inside of this 620 over here, inside of this 640. So let's do something like this. If you don't have a lot of data points, you have to be kind of use a little bit of artistic sense. So 800, 600, so we go between those two values. Here's 650. So now we can just join that up. Okay, and that suggests, okay, here we have the top of the hill, right? And we have an 800, so we have to have another contour line. Has to be on the outside of that. Obviously, this has to make a closed circle too. So something like that. Now we can finish our map. So we have 700, now we have 600 again. Here's 5 over here, so we have to go outside of that. And here's a 600, so we can go right through that. Point. Then we have 500, so it goes between these two. Again, it's higher on the left now and lower on the right, so the 550 is going to be to the left of that line. And then finally 400. So now we have completed the right side of the topographic map. Make another point here in a minute. So before I do that, let me finish this other side of the map. Start down here at the bottom. Now, when we cross a stream or something, the topo lines have to match up on both sides. So I have to start the one, this is a 100 one. I have to start it on that same place. So there's 200, so I have to stay inside. So this is 130, so that's higher. So we're going now higher as we go to the left. So 200, I have to start up here where this 200 was. So I can go right through that because that's a 200. And this is also a 200, so I go right through that point. So that's a fairly easy topographic line to make. 300 is next. I have to go inside of this. I have to go between the 200 and 400, about halfway. There's 350. Again, 300 down here, I can go through that. 400, somewhere about here. And I have to go inside of that 412, not through it. Again, between the, and then we have 500. So fortunately, we have 500 value here to go outside of the 480, inside of the 520, closer to the 510, and off the map. And then 600. Don't have a lot to go on, just go all the way down here inside of the 620. And then here's 700 because we have a 710. Okay, so we've now completed our topographic map. Now, a couple of important points for understanding how topo lines work is, here's a hill. And when you go up to the top of the hill and down the other side, the contour lines have to repeat. So here's 60, 600, 700, 800, reach the top of the hill, which is a little over 800. Now, when you come down the other side, you have to hit 800 again, and then 700 again, and then 600, and go back down again. So this gets particularly important when the high point goes off the edge of the map. So you have to realize that you're going to have a duplicate topo line as you go over the top of a hill. The same thing is when you go through a valley, right? So you have 300, 200, go down the valley and up again, and you have 200 again on the other side. 300, 400, 500, 600. So that's always important to remember. Also, there's what's called the law of V's. So here's a stream. Topo lines always V up a stream. So here's your V, and the points of the V's point upstream. So the water is flowing from the top of the map to the bottom. So this is higher elevation than down here. So the water is flowing from the top to the bottom of the map. And the topo lines V upstream. That's always important to check your topo lines. Be sure that they V when they go upstream or up a valley. Okay. So the next step is going to be to make a cross section. So here we have an island. We already have the topo map drawn with all the topo lines. This tells the values on a topo map. It'll indicate the values of the lines. Usually it's every fifth line will have a number on it. So this says 1,000, 2,000, 3,000, 4,000, 5,000. In this case, each one of these lines is an increment of 1,000 feet. Notice also that the highest value, which is something you want to pay attention to, the highest value on the map here is a little over 13,000 feet. So it goes from 0 at sea level to 13,000 feet. So you want to keep that in mind. So the first thing that you do to draw now what we're doing is we're making a profile. So this is, what does this look like sideways as a profile? So we're going to draw a profile from this point to this point across that line. That's the profile line. So the first thing you do is get a piece of paper, mark the outside edges here, and now you just make a tick mark for each of these lines where your piece of paper, where this cross-section line intersects a topo line. And we know what the contour interval is. It's a contour interval of 1,000 feet. So we need to be aware of that. And what's good to mark is when you hit either a valley or the top of the hill. So in this case, we have the top of the hill. We notice that it's 1,300 feet. So we want to make a note of that, so we remember. So both of those values, again, when you go up and then down again, those could both be the same. So both of those topo values are 13,000 feet. And now you're going back down the other side. Again, just make tick marks, and there we go. Okay, now what we need to do is we need to transfer this onto graph paper. And I've already made the initial steps here by drawing the two axes. So this is the distance across the map, and I used the value. This is the scale here, and this is miles. So I'm going to use the mile scale. So this is marked off in miles, the same as the map. So this is miles on this side, and this is feet over here. Okay, and I decided, one thing you have to do is decide what your vertical scale is going to be. Now I'll come back and talk about this a little bit, but you're always doing vertical exaggeration, almost always. That means that your vertical scale is much exaggerated over the actual topography. In other words, if you wanted to do it in real elevations, these two scales would be the same. So your profile would be very, very tiny, be very low, because obviously these are in miles, okay? So in order to properly visually show the topography, you exaggerate the vertical dimension. So I have a fair amount that's called vertical exaggeration in this, right? So then I have my piece of paper with its tick marks, right? Remember, each one of these tick marks was 1,000 feet. So then I just carry these values up and just make a mark, just make a dot where it intersects. So that's 1,000 feet. There's 2,000. They just carry these up. 3,000, 4,000, 5,000, 6,000, 7,000, 8,000, 9,000, 10,000, 11,000, 12,000, 13,000. That's where we are here. And then another 13,000, which is there. And now we go down again. So now we have 12, 11, 10, 9, 8, 7, 6, 5, 4, 3, 2, and then finally 1. And then here we're back to 0. Right? So there we go. Then the next step is simply to join up the dots, right? So this is fairly easy. Start at sea level. And then we just join those points up as smoothly as we can. Okay, now we've reached the top, but the top of that mountain is a little bit higher than 13,000 feet. So the line goes a little bit above that, and then comes back down again the other side. So there is our topographic profile going across this island. And so you can do this with any topographic map, and you can turn the topographic map into a side view of the topography, so you can another way of visualizing that data. So you'll be doing both of these things in your lab, and I hope this provides a helpful introduction.